Today on How It's Made. Manhole covers, fitting a round peg into a round hole. Range hoods, removing those unwanted nasty niffs. Artificial logs, the secret behind those fiery fakes. And snowmobiles, a far cry from a one-horse open sleigh. But first... Manhole covers are those metal lids on maintenance holes in the road. Workers lift them to enter and repair sewers and other underground utilities. Foundries make the covers out of heavy-duty cast iron, so they last for decades and don't budge under passing traffic. This company makes hundreds of models of manhole covers and collars, the rims upon which the covers sit. They come in two types of cast iron alloy, either ductile iron, which has magnesium to reinforce it, or grey iron, which is just as strong but heavier. To make the cover, they first have to make a mould. This one's got the design of the cover's top carved into it. Workers pour in 300 kilograms of sand, mixed with glue and a hardener. For the underside of the cover, they repeat the step in another mould. A worker creates a channel in the sand mould, through which they'll pour the molten metal. He plugs the hole with a wooden block to preserve the cavity beneath. He removes the block and briefly reinserts the pipe to ensure the cavity hasn't caved in. It takes about 15 minutes for the sand mix to harden. A machine then inverts each box and vibrates to shake out the mould. To make one manhole cover, workers will join moulds of the top and bottom sections. Alignment lugs and glue between the sections help them align properly and form an airtight seal so molten metal won't leak out. Next, a machine flips the bottom mould, moves the top mould into position below, then mates the pair. The factory buys scrap metal from demolition sites and also recycles its own. It'll melt these metals with certain minerals to enhance the mix. Graphite to make it malleable, silicon to make it stronger, and magnesium to make this batch of ductile iron lightweight yet strong. Here a giant magnet picks up chunks of recycled iron and steel. The metal is preheated to 420 degrees Celsius, then transferred to a furnace. There at 1500 degrees Celsius, it takes about half an hour to melt enough metal to make 35 covers. Workers then transfer the molten metal to a cauldron and add more silicon. This evens out the consistency so it's easier to pour. Besides the channel for pouring in the metal, some larger moulds have vent holes to evacuate burning gases. It takes about an hour and a half for the metal to harden. A conveyor then drops the moulds into a container and breaks them open. Using a hook, they pick up the casting. This one's a collar weighing about 100 kilos. They knock off the remaining bits of sand and excess bits of metal that form during the casting. These scraps get recycled into a new batch of iron. Manhole covers vary in size according to the specifications ordered. Most are roughly the diameter of a car tyre. The average weight, about 63 kilos. A worker now smooths out the edges of the collar, and then the perimeter of the cover. This way it'll sit flush on the collar. This machine tests the strength of the cover by applying pressure. Each 2.5 centimetre area must withstand the weight of a car. They paint the covers and collars by dipping them in a bath of black tar. Once dry, the pieces have a rust-resistant finish that lasts for decades. And we expect them to last, especially as we have to drive over them every day. It wasn't until about 1800 that metal stoves with flues vented steam and smoke outdoors. Today, factories make encased fans that powerfully ventilate and also light the hob of your oven. The range hood sits above your simmering masterpiece, removing nasty niffs from your kitchen. No matter how well you cook, steam and smoke are inevitable. Fortunately, the range hood's fan clears the air in seconds. Production begins with this computer-guided machine. It cuts out a sheet of galvanized steel to make part of the hood's housing. A 300-ton press then perforates the sheet and cuts out up to 50 openings for screws, wiring, and exhaust outlets. Another panel for the housing is inserted in a 25-ton press. The machine bends the steel in 2 places. This component will be used to make a circular channel that evacuates smoke and steam, which often contains grease particles. Another machine with 3 rollers forms the circular channel that fits around the blower to direct air out through the exhaust. Here, a spot welding machine joins 2 corners of the hood's housing. This is mainly for aesthetics. A weld looks better than a screw or bolt. This 80-ton press bends the hood's shell, making one of 8 folds that gives the component its final shape. Plastic coating that protected the steel during the cutting is removed. A sticker with a product ID is applied. Then, a pad printing machine marks the brand name, one of 12 this factory produces. This is the first of 8 stops on an assembly line. A transformer is installed to power the blower's motor and 2 halogen lights. This circuit board regulates several functions, including 3 light intensities and the blower's 4-speed motor. The board is attached to the housing with 3 screws. This panel has lights that indicate which functions are active. Next, the blower's 165-watt electric motor is installed. The motor attaches with 3 screws into rubber bushings that reduce noise. Then, light sockets made of heat-resistant plastic are attached. The blower's housing snaps into place around the motor. A little silicone on the housing ensures an airtight seal around the blower. Then the blower wheel is installed. The lights are tested. Pressing this button 3 times increases the intensity of the light. There's 1 button for each of the motor's speeds. After a panel is snapped on to enclose the hood assembly, a plastic ring is attached to direct air through the blower. A computer system tracks each model's assembly. When workers complete a step, they input it into the system. An optical scanner also senses when they remove a part from one of 25 cubby holes, like these removable air filters made of mesh aluminium. The tracking system is called poker yoke, a Japanese-inspired method that ensures thorough assembly. It follows each model until workers place it in a box for shipping. The system's final task is to ensure that the guarantee card and installation manual are put in. Once the box has been stapled closed, a machine with suction cups picks it up and stacks it on a pallet. All this work so you can stay in the kitchen even if you can't stand the heat. Coming up on How It's Made, artificial logs. We'll answer the burning questions. And snowmobiles, a very cool way to travel. See you after the break. If you're in the mood to light a cosy fire, there's no longer any need to put on your coat and boots and trudge through the snow to the outdoor woodshed. Nowadays, you can buy a box of man-made logs. The environmentally friendly brands pollute less and are safer for your chimney. And it means a lot less hassle for you. These artificial logs are made entirely of compressed sawdust. Their moisture content is less than 9%, compared to 30% in real firewood. The compression and dryness combined makes these man-made logs easier to light than real ones. They don't throw sparks while burning, and they produce 300% more heat than real firewood. The high temperature burns up the gases better, so the logs emit up to 50% fewer pollutants. And they produce fewer ashes and far less creosote, a highly flammable tar that's a natural byproduct of wood burning. Creosote buildup in a flue can cause a chimney fire. The sawdust comes from pure natural hardwood, mostly oak and maple. The log company buys it from factories that make hardwood flooring. As the sawdust is clean and the log factory doesn't add chemicals, it's safe to cook over the fire. The moisture content is so low because the wood it came from has already been dried in huge ovens to make the flooring. The sawdust arrives in different consistencies, so the first step is to put it through a grinder to make the particles uniform in size. The next step is the key one, compression. At a rate of 2,500 kilograms per hour, an air-blowing system moves the sawdust from the grinder directly into a compression machine. The machine is a giant cylinder with a piston that moves inside. The piston compresses the sawdust using extreme high pressure, 1,400 kilograms per square centimetre. The result is a 12-metre-long compressed sawdust log. Unlike some other brands of artificial logs, this one contains no binding agents, which can pollute the air. The secret to making the sawdust stick together is the high compression. The intense heat it creates bonds the natural resins in the sawdust. As the log exits the compression machine, a cutter shapes a flat edge. This is a safety feature. With the flat edge on the bottom, the logs are easier to stack in the recommended 3-log configuration, and they don't roll out of position. Now a guillotine chops the 12-metre log into 40 smaller logs, each one 30 centimetres long. A separator pulls them apart. The company also produces a 27-centimetre log. The logs drop onto a conveyor belt that leads to the packaging area. The factory boxes its logs with instructions and 2 fire starters. The starters are made of sawdust and candle wax, much more effective than using newspapers to get the fire going. Other artificial logs can break easily because they're less dense. But not these ones. The high density of this company's logs translates into more burning time. 3 logs will keep your fireplace alight for about 3 hours, by which time that fella's hand might have stopped aching. Snowmobiles are widely used in the Arctic, but the small population makes for a small market, so most snowmobiles are produced for recreational purposes in parts of North America. The number of snowmobiles in Europe is still relatively low, although they're catching on as a cool way to travel. Snowmobiles need a rock-solid build to keep the riders safe and comfortable as they often travel across rugged terrain. It all begins with an aluminium alloy frame. The pieces arrive partly assembled to the radiator. The robot spins and positions the frame. A computer-guided machine punches holes and inserts rivets directly into the frame with great precision. The process bonds the parts tightly so they can't vibrate. Next comes the rear suspension, aimed at making the ride as smooth as possible. Inserting this plastic slide into the runner minimizes friction between the track and the suspension. A conveyor belt carries this suspension system through several stations. Wheels and sprockets will turn the track that grips the snow. The suspension kit, with springs and coils, goes directly into the runners. Along with these shock absorbers, the suspension will fit snugly into the snowmobile's frame. For now, everything is tightened manually. Assembling the transmission system starts with this countershaft. First, a high-performance brake disc made of forged steel is installed. The chain case fits snugly on top, thanks to the ridges on this ring. This die-cast aluminium casing will house 2 gears and a chain. This bolt connects to a spring that keeps the gears and chain tight as they turn. The chain tightener must slide smoothly back and forth in its groove to keep the chain's tension even. This test checks that the spring expands and compresses properly. Now comes the oil gauge. It's essential that oil lubricates the parts thoroughly because the motor will generate a great deal of friction. The transmission fits on top of the frame. These coils, springs, runners and wheels fit easily into the rubber track. The rear suspension system connects to the track system, while this white plastic sprocket connects the track to the transmission. The speed sensor attaches directly to the sprocket. Four high-grade steel bolts anchor the rear suspension system to the frame. They're so strong that the suspension can withstand the vibrations that come with high speeds. Now for the engine assembly. Bolts attach the electric starter directly to the engine. The fuel-injected engine generates a lot of heat, up to 700 degrees Celsius. This shield has layers of insulating wool that act as a heat barrier to protect the rider. The engine's made of cast aluminium, so it's relatively light, just 45 kilograms, and it propels the snowmobile up to 200 kilometers an hour. Now for the front of the snowmobile. This front suspension system requires a different assembly from the rear one. A hoist brings it all together. The petrol tank is made of lightweight molded plastic rather than metal. They install the throttle assembly and a few more functional details. These lightweight aerodynamic plastic side panels give this snowmobile a sleek look. And now, the final step. The zero-gravity hoist lifts it all onto a pallet. Polystyrene sheets protect the snowmobile during transport to the retailer. From start to finish, it's taken 3 hours to assemble this showroom-ready snow-traveling machine. So, whether it's metal and round over a hole in the ground, or practical and strong, preventing a nasty pong, or perhaps it's not quite real, but heating you a great deal, now you know how it's made.